What if everything you believed about which country leads the world in technology is completely wrong? Right now, something is happening in China that most people will not read about in the news, will not see trending on social media, and will not fully believe when they first hear it. And by the end of this video, the way you see human progress will never be quite the same again. Before we go any further, if you are the kind of person who stays curious, who wants to understand the world before everyone else does, then hit that like button, subscribe, and share this with one person who thinks they know everything about the future. Because after this video, they will realize they do not. Now let us get into it. A soldier controls a military drone with nothing but his mind. A city of 2.5 million people moves without a single traffic light. A machine burns 7 times hotter than the core of the sun. A satellite sends messages that no computer on Earth can intercept. And on the floor of the Pacific Ocean, data servers hum quietly in the cold and dark, running perfectly, completely unattended. This is not science fiction. This is not a research proposal. This is China. Today. The gap between what China is building right now and what the rest of the world is still planning is wider than most people realize. Not in a decade. Not after the next election cycle or the next round of government funding. Right now, as you watch this, China is deploying technology that other nations are still arguing about in committee rooms. We are going to walk through 12 of these inventions today. 12 technologies that feel like they were borrowed from 30 years in the future and quietly installed into the present. Some of them will seem almost impossible. Some will genuinely unsettle you. And at least one will make you stop and ask a question you have never thought to ask before. Let us start with something that changes the very idea of what it means to control a machine. Imagine a soldier standing completely still. No controller in his hands, no screen in front of him, no voice commands spoken into a headset. Just a quiet expression of intention. And somewhere above him, a drone banking left through clear sky. This is not imagination. China has already built it. Researchers in China developed a brain-computer interface that reads electrical signals produced by the human brain in real time. A tiny chip positioned near the brain picks up those signals, decodes them, and transmits the command wirelessly to a connected drone. When the operator thinks about turning left, the drone turns left. The response time is so small it barely registers on instruments. Thought and action collapse into the same moment. In real military situations, that speed is not just impressive. It is transformative. Human hands have limits. They fatigue. They hesitate. They take time to move from one position to another. Human thought does none of those things. A thought-controlled weapon system can respond in the time it takes a hand to even begin moving. You may have heard of Neuralink, the brain chip company that attracts enormous media attention in the West. Neuralink is still conducting early trials with a very small number of human patients. It is groundbreaking work and the potential is real. But China's brain-computer interface program has already moved past the laboratory and into active defense applications. The gap between concept and deployment is where China continues to surprise people. What this means for the future of warfare, of piloting, of operating any complex system remotely, is difficult to overstate. Cockpits without pilots, control rooms without controllers, entire categories of human capability driven purely by thought, at speeds that no human hand could match. The future of control is not a joystick, it is a mind, and China has already built the bridge between the two. Now, from something that happens above ground, we move to something that happens above the atmosphere entirely. Something so secretive that even the people watching it most closely do not fully know what it is doing. In 2022, a vehicle launched quietly into orbit. It looked roughly like a scaled-down space shuttle. It carried no crew. No announcement was made about what it was carrying. It rose above the Earth, completed an orbital mission that lasted months, and then descended on its own and landed cleanly on a runway. No parachutes, no ocean splashdown. Just a smooth, controlled landing, as if it had simply returned from a long trip. This is the Shenlong, and it is one of the most mysterious machines currently operating on or above this planet. The Shenlong is a reusable spaceplane. It launches on a rocket, completes its mission in orbit, and then glides back to Earth and lands like a conventional aircraft. The fact that it is reusable is what makes it such a serious technological and strategic achievement. Traditional rockets are used once and discarded. That is the equivalent of building an entire airplane, flying it once and then throwing it away. Reusable spacecraft collapse the cost of reaching orbit. They allow a country to go to space more frequently, more flexibly, and far more cheaply. The mystery deepens when you ask what Shenlong actually does up there. It has completed multiple missions. Each time it returns, China releases almost nothing about the nature of the mission. No cargo list, no scientific summary, no public briefing. The silence is deliberate and total. The United States operates a similar vehicle called the X-37B, which has also flown classified orbital missions for years. But here's what matters. China developed Shenlong independently, using its own engineering and its own funding, and did so in a fraction of the time it took the American program to mature. A country that can send a reusable autonomous spaceplane on secret orbital missions whenever it chooses has a kind of access to space that most nations cannot begin to match. Intelligence, communications, experiments, strategic observation, all of it becomes possible at costs that fundamentally change the calculation. Nobody outside China knows exactly what the Shenlong carries or what it does. That mystery is not a weakness in the story. That mystery is the point. From a secret vehicle above the clouds, we move to a machine on the ground that is attempting something human beings have chased for over 60 years. Something that, if it works, would end the energy crisis permanently. Here is a number that should stop you for a moment. 120 million degrees, the core of the sun burns at approximately 15 million degrees. China built a machine that burns 8 times hotter than that. Not for a split second. Not in a flash. For over 1,000 continuous seconds. And then they pushed further. This machine is called EAST, the Experimental Advanced Superconducting Tokamak. It is China's artificial sun, and the reason China wants to create something hotter than the actual sun is because that extreme temperature is the key to unlocking nuclear fusion. Fusion is the process that powers every star in the universe. When hydrogen atoms are forced together under tremendous heat and pressure, they fuse, and in doing so, they release an enormous burst of clean energy. Unlike the nuclear power plants we use today, fusion does not produce long-lived radioactive waste. It does not depend on uranium. Its fuel is hydrogen, which can be extracted from seawater. Seawater that covers more than 70% of this planet. If fusion power becomes practical and deployable, a single fusion plant could power a country the size of Germany indefinitely. No emissions, no fuel scarcity, no supply chain, just clean, nearly limitless energy drawn from the same process that makes stars burn. The scientific community has chased fusion for more than 6 decades. For most of that time, the joke in physics circles was that fusion energy is always 30 years away. It became a symbol of something perpetually promised and perpetually delayed. China is changing that conversation. There's a massive international fusion research project called ITER, backed by the United States, the European Union, and dozens of partner countries. It has been under construction for years. It is not finished. Meanwhile, China built EAST independently, broke multiple world records for plasma temperature and duration, and is already designing the next generation reactor. The implications of getting fusion right are almost impossible to fully absorb. The wars fought over oil would lose their cause. The carbon emissions from power generation would drop towards zero. The energy constraints that limit development for billions of people would lift. The entire geopolitical architecture built around controlling fossil fuels would shift. China is not a participant in the fusion race. They are setting the pace. Now, while China is rewriting the rules of energy, they are also rethinking something far more immediate. The way millions of people move through a city every single day. Imagine floating above traffic, not in a helicopter, not in a drone taxi, in a quiet pod, hanging beneath an elevated rail, gliding silently forward on magnetic levitation, with no wheels touching any surface, no engine producing any sound, and no driver sitting at the front. China built this. They call it the SkyTrain. The SkyTrain is a suspended maglev transit system. The pods hang below an elevated track, lifted and propelled entirely by magnetic force. No friction, no mechanical contact, no fuel combustion, just smooth, silent movement above the streets. The system runs itself. Cameras and sensors map the environment in real time. Artificial intelligence manages routing, spacing, and speed. If a component begins to show signs of wear, the system identifies the problem automatically and schedules the repair before anything fails. The infrastructure maintains itself. Because the pods hang below the rail rather than sitting on top of it, the center of gravity is lower. That makes the system more stable at high speed, safer in extreme weather, and structurally simpler to build than conventional elevated rail. Now, consider the contrast. In New York City, extending a single subway line by a few kilometers took more than 20 years and cost billions of dollars beyond its original budget. In the United Kingdom, a major high-speed rail project called HS2 suffered so many delays and cost overruns that significant sections were abandoned entirely. China builds entire elevated transit networks in under 2 years. This is not simply a difference in funding. It is a difference in how a society decides to move. And it raises a question worth sitting with. If technology this clean and this efficient already exists, what exactly are other cities waiting for? All right, before we continue, let us pause for a second. If this video is making you see something differently, if it is connecting dots you did not know needed connecting, do something right now. Screenshot this video and send it to someone who needs to see it. Drop a comment below and tell us which invention is hitting hardest for you. And if you have not already, subscribe, because what we cover next is going to be just as revealing. as what we have already discussed. Let us talk about secrets, specifically about a future where keeping a secret becomes physically guaranteed. Every digital message you send today is protected by encryption. Encryption works by scrambling information mathematically in a way that requires a specific key to unscramble. The assumption that keeps the system safe is that cracking the encryption would take an impossibly long time, even for the most powerful computer. That assumption is running out of time. Quantum computers, which process information in fundamentally different ways from conventional computers, are becoming increasingly capable. When they reach sufficient power, the encryption protecting your bank transactions, your private messages, your national infrastructure becomes breakable. The security of the modern internet is built on a foundation that is beginning to crack. China built a satellite to solve this problem before it fully arrives. The satellite is called MISHIS. It uses quantum physics to transmit messages that are physically impossible to intercept without being detected. The method involves quantum particles called photons, linked together in a state called entanglement. When these particles carry encoded information, any attempt by an outside party to observe or copy that information disturbs the particles themselves. The disturbance is detectable. The eavesdropper cannot hide. You cannot hack a quantum message. Not with a supercomputer, not with any technique that currently exists or that classical physics permits. The protection is not technological. It is written into the laws of nature. China used MISHIS to conduct the world's first quantum encrypted video call between Beijing and Vienna, over 7,500 kilometers. It worked without interruption. Other nations are pursuing quantum communication. The research is active in the United States, in Europe, in Japan, but China was the first to launch a working quantum satellite and demonstrate the technology in a real-world, long-distance application. In a world where information is the most valuable resource, owning a communication network that cannot be compromised is not just a scientific achievement. It is a strategic one of the highest order. From communication that cannot be broken, we move to movement that most people still consider impossible. A flight from Beijing to London takes roughly 10 to 11 hours today. You sit in a seat, eat whatever they bring you, try to sleep, and arrive stiff and disoriented. China wants to make that same journey take 90 minutes. Hypersonic flight means traveling at more than 5 times the speed of sound. At those velocities, the air in front of the aircraft compresses so violently that it generates extreme heat. The engineering challenge has always been building a vehicle that can survive that heat while carrying passengers safely. China has been developing hypersonic technology primarily through its defense program, and significant progress has been made in solving the heat management problem. That same technology is now being adapted towards civilian aircraft. The concept is a plane that flies at the upper edge of the atmosphere, above most air resistance, at speeds that would make current commercial jets appear stationary by comparison. Beijing to New York in under 2 hours, London to Sydney before a standard morning meeting begins. The West's most celebrated attempt at supersonic passenger travel was the Concorde, which flew at roughly twice the speed of sound and was retired in 2003. No Western nation has operated a commercial supersonic passenger route since. China is not trying to match the Concorde. The target is 2.5 times faster. The technology is still in development and testing. But the engineering foundations are being laid using real breakthroughs from active programs, not theoretical sketches. The direction is clear. Now, from the speed of individual travel, we expand to the scale of entire cities. Because China is not just building faster vehicles, they are building a city that thinks for itself. Most cities were not designed, they accumulated. A road was built here because there was already a path. A neighborhood grew there because a factory opened nearby. The infrastructure of most modern cities is essentially a historical accident. Layers of decisions made in different eras stacked on top of each other and struggling to coexist. Xiong'an is the opposite of all that. Announced in 2017, Xiong'an is a brand new city being constructed from open land about 100 kilometers southwest of Beijing. It is planned to house 2.5 million people, and from its very first design decision, it has been built with artificial intelligence at the center of everything. Every road, every building placement, every underground utility network was laid out by AI systems that ran through millions of simulated scenarios and identified the most efficient possible configuration. Not what seemed reasonable. What the data proved was optimal. There are no traffic lights in Xiong'an. An AI platform monitors every vehicle moving through the city simultaneously and coordinates the flow of traffic in real time, continuously adjusting as conditions change. No lights, no signal cycles, no sitting at a red at midnight with empty roads stretching in every direction. Beneath the streets, smart pipe networks monitor their own condition. If a water pipe begins developing a fault, the system detects it before failure occurs and schedules a repair. The city identifies its own problems and addresses them before they affect anyone. A well-known smart city project in Toronto, backed by one of the world's largest technology companies, spent years in planning for a small experimental neighborhood. It was eventually canceled, largely because of concerns about data privacy and public oversight. Shungan is not a neighborhood. It is a city, and it is already being populated. The systems are already running. From a city that manages itself, we move to a navigational system that gave China something it had never had before: the ability to know exactly where anything is, anywhere on Earth, without depending on anyone else. For decades, there was essentially one global satellite navigation system. The United States built it, launched it, and maintained it. The entire world, every phone, every ship, every commercial aircraft, every precision instrument, ran on that single American network. The convenience was enormous. The strategic dependence was also enormous. China recognized that relying on another country's navigation infrastructure was a vulnerability. If access were ever restricted or interrupted, the consequences would reach into every corner of modern life. So China built its own system, called Beidou. Beidou now operates with 35 satellites covering the entire globe. In the Asia-Pacific region, its positional accuracy exceeds that of the American system. Standard GPS positions a device to within approximately 30 centimeters. Beidou can do it to within 10 centimeters. 10 centimeters is roughly the length of your hand. That difference matters far more than it might sound. For autonomous vehicles, 10 centimeters is the difference between staying in a lane and drifting out of it. For precision agriculture, it means the difference between a machine that plants correctly and one that wastes seed and soil. For emergency response and construction, the precision changes what is possible entirely. But Beidou does something the American system was not designed to do. It includes a two-way short messaging function. A device connected to Beidou can not only receive location data, but can also send a brief message back through the satellite network. Even with no mobile signal, no internet connection, and no cell tower within hundreds of kilometers. In disaster zones, remote wilderness, and open ocean, that capability saves lives. Today, roughly 70% of smartphones in China use Beidou. The network continues to expand its global reach, and for any nation that has quietly worried about what happens if GPS access is ever used as a political tool, Beidou is becoming an increasingly attractive alternative. Navigation solved. Now let us go somewhere most people have never thought about. 3,000 meters below the surface of the Pacific Ocean. Every modern device runs on rare minerals: cobalt, manganese, nickel, lithium. These materials are inside electric vehicle batteries, inside the chips in your phone, inside the infrastructure of every technology discussed in this video. And right now, the supply of those minerals is controlled by a very small number of countries, making them one of the most significant pressure points in global politics and supply chains. China found a different source: the ocean floor, thousands of meters below the surface of the Pacific. In the crushing dark where no sunlight reaches and no human could survive unprotected, there are fields of rocks called polymetallic nodules. These nodules formed over millions of years and are packed with exactly the rare minerals that modern technology depends on. The estimated value of the nodules sitting on the floor of the Pacific alone runs into the trillions of dollars. Almost none of it has been touched. China developed autonomous underwater robots specifically engineered to go down and retrieve them. These machines operate at depths where pressure would destroy conventional equipment. They navigate the ocean floor, collect the nodules, and transport materials to the surface without a human operator directing each movement. They work independently in complete darkness under conditions that no manned operation could sustain. Other countries have discussed deep-sea mining for decades. Some exploratory work has been done, but China has moved to actual deployment of operational systems, ahead of everyone else, at a scale that makes the difference between theoretical possibility and functioning supply chain. Reducing dependence on other nations for the raw materials of advanced technology is not just an economic strategy. In a world where supply chains are increasingly deployed as instruments of political pressure, it is a form of sovereignty. From the floor of the ocean, we now look up, much further up. In the mountains of Guizhou province in southern China, there is a structure so large that 30 football fields could fit comfortably inside its dish. This is FAST, the 500-meter aperture spherical telescope. It is the largest radio telescope ever constructed by human beings, and its size is not decorative. It is functional. In radio astronomy, the size of the dish determines what you can hear. A bigger dish captures fainter signals from greater distances. FAST is so sensitive that under the right conditions, it could theoretically detect a signal as weak as a mobile phone transmitting from the surface of the moon. Scientists use FAST to study pulsars, which are dense rotating stars that emit regular radio pulses and serve as some of the most precise natural clocks known to science. They use it to map the distribution of hydrogen gas across enormous stretches of the galaxy. They use it to investigate the source of powerful, mysterious bursts of radio energy that appear briefly and then vanish. And they use it to listen, systematically and seriously, for signals that might indicate the presence of intelligence beyond Earth. The previous holder of the record for the world's largest radio telescope was the Arecibo Observatory in Puerto Rico, which was part of the American Scientific Network. Arecibo collapsed in 2020. FAST is not a replacement. It is twice the size and significantly more capable. To protect FAST from interference, China established a radio silence zone extending several kilometers in every direction from the telescope. No mobile phones, no wireless networks, no radio broadcasts. They relocated thousands of residents to make it possible. The scale of institutional commitment required to silence a region of the country so that a scientific instrument can function at its maximum capability is something most nations would not consider and fewer could execute. What FAST discovers in the coming decades could redefine humanity's understanding of its place in the universe. And that is not an exaggeration. It is simply the scale of what the instrument is capable of. And now, for the final invention on this list. One that you are probably benefiting from right now without knowing it exists. Every time you stream a video, send a file, search for something online, or use any connected service, your request is processed by a server. Those servers live in data centers. Data centers are enormous. They run constantly, and they generate staggering amounts of heat. Keeping them cool requires a continuous supply of electricity, often enough to power a small city, and vast quantities of water for cooling systems. China decided to take a different approach entirely. They decided to put the servers underwater. Off the coast of Hainan Island, China deployed the world's first large-scale commercial underwater data center. The servers are enclosed in specially designed sealed modules and lowered to the ocean floor. The ocean cools them. Not an air conditioning system, not a cooling tower, not a freshwater supply being consumed at industrial rates. The sea does the work continuously for free. The results are significant. The underwater facility uses a fraction of the energy required by equivalent land-based infrastructure. The stable, cold temperature of deep water provides a nearly ideal operating environment for servers. The sealed, pressurized conditions actually reduce the rate of hardware failure compared to land-based installations exposed to air, humidity, and temperature variation. Microsoft conducted a small experimental version of this idea in 2018, a pod roughly the size of a shipping container, submerged off the coast of Scotland as a proof of concept. It was clever, and it worked. China looked at that concept and scaled it to a fully operational commercial facility, handling real traffic for real users, running today. In terms of energy savings, environmental impact, cost efficiency, and the sheer creative logic of using the ocean as an infinite free cooling system, underwater data centers may be the most quietly brilliant idea on this entire list. And that is 12. 12 inventions. One country, all of them real, all of them operating or actively in development right now. A soldier steering a drone with thought, a secret spacecraft completing silent missions in orbit, a machine burning hotter than the sun, chasing the energy of the stars, quantum satellites making eavesdropping physically impossible, hypersonic planes preparing to collapse the distance between continents, a city that manages its own traffic, its own pipes, its own infrastructure, a navigation system rivaling and in some ways surpassing the best in the world, underwater robots mining minerals from the deep ocean, the largest ear ever pointed at the sky, servers running silently and efficiently on the ocean floor. The question this raises is not whether China is advancing. The question is what the rest of the world is doing with the time it still has. Because technology at this level does not stay confined. It spreads. It shifts economies. It rewrites the rules of who holds power and who depends on whom. And the countries and people who understand what is happening right now will be far better prepared than those who do not notice until it is already finished. You noticed? You'll watch this to the end. That already puts you ahead. Now here's the challenge. Do not let this just be interesting. Let it be useful. Share this video with someone who makes decisions, teaches, builds, or leads. Leave a comment below with a single invention from this list that you think changes the most about how the world works. And if you want more content like this, content that tells you what is actually happening before it becomes common knowledge, you know what to do. The future is not being announced. It is being built. Quietly, quickly. And it is already here.